this tool, and then also we'll discuss availability and pricing. So this is Bluejay. You can see some pictures there of what it looks like. So this product was really created out of a need that we saw in the market to expand data and communication beyond just a wired connection. So it's primarily created for a wireless source of connectivity for development and service, both engineering and then in the field addressing issues in service. It's built with a focus on a mobile platform. It's designed to be a high volume, low cost alternative to some of the more expensive wired connections. It's designed to be flexible for eventual expansion to other products and for a multiple number of use cases. And it really was created out of a need to expand what we call our Raptor platform into new markets and new opportunities. Also, as a part of the overview, we need to be clear to what it's not. It is not an ELM 327 OBD reader or anything related to that. Those products have their place in the market, but they're unidirectional and have limited capability. We wanted to design a tool that could be used for more widespread adoption and development, and that really fulfilled a greater need that we saw. So now let's jump into a little bit more detail on the specifications. The Bluejay uses Bluetooth 3.0. You know, one of the initial pieces of feedback we got was that people were concerned about using Bluetooth. So because of, you know, early on Bluetooth wasn't an incredibly reliable protocol, but we wanted to make that one of the priorities in our development, and so we selected Bluetooth 3.0 as a way to balance costs and what was available, and have tested it, and it supports all the data rates that we need, and the reliability is there. So we're excited about, you know, full Bluetooth capability. It's, like I mentioned earlier, it's going to be fully bidirectional, which means you can send and receive CAN messages with no limit on the baud rate or amount of messages that you send, and it's compliant with CAN 2.0 A and B, and therefore J1939, and any CAN protocol will work with the Bluejay. It has a very wide operating range in terms of voltage, so that it can be used on both 12 and 24 volt applications. It is RP1210 compliant, which just means that it can be used with a number of different automotive service and calibration tools. It's Android compatible, both with a wired and wireless connection, as you'll see later, and that optional USB connectivity just gives you some more options with potential applications. Some more design features for the Bluejay. It's very small to be able to be packaged in lots of different locations. It's easy to hold. It has 3 LEDs that give you information on CAN bus activity, if there's any airframes, and a status of your Bluetooth connection. And Matthew, feel free to jump in here if I leave out any of the details. Matthew's very familiar with the design. The DB9 pinout uses kind of the standard DB9 CAN bus pinout. There is a number of features that supports, and then micro USB we added as well. You can kind of see that in the top image there, just peeking out, but that allows you to support serial data transfer if you prefer that over the Bluetooth communication.
I'd also like to mention that the power comes over the DB9 connector. It just comes through the CAN bus and is not powered over micro USB. It's for data only.
Yeah, so the power comes through that DB9. We've had that question before as well. So that's where the power and the CAN data that's being sent and received comes into that DB9. So now let's talk about some applications where we see the use of Bluejay and widespread adoption. So, like we said, one of the places that we wanted Bluejay was for our Raptor platform, and that includes the lineup of PC tools that we have in both Raptor Cal and Raptor CAN, which is an alternative interface for calibrating and flashing and communicating with controllers on different systems. Additionally, we will support, for those MotoHawk users, MotoTune and MotoService through Bluejay. As we mentioned before, it's RP1210, so it can be used with any RP1210 compatible tool. And then it can be set up with your Bluetooth driver on your computer or a USB connection. And another obvious application for Bluejay is mobile markets, which is really the focus for what this product was developed for. We have Android driver support that we've built up, which handles the processing of the data between your control system, the Bluejay, and the tablet or phone. We have custom display apps built to customer requirements, so we can take your graphics that you have already or that you build up, and we can integrate that into a custom app. Alternatively, we have some gauges and libraries of graphics we can use to build an efficient display. And really the benefit of the Bluejay is it allows you to tap into this low-cost tablet market, high volume consumer electronics, and use that as a part of your control system, because we saw a need to have the end user, the customer, the consumer interface with their control system with the devices that they were already familiar with. Additionally, we have the ability to do CAN data logging and analysis and some service and engineering tools. And again, this is supported both wirelessly through Bluejay or wired through USB serial data. So the first and probably most common application that you could use Bluejay for is in your control system where you have a controller talking on CAN in your network and you want to access some of that data and you want to interact with it. And so Bluejay allows you to send and receive messages to your tablet, which can be mounted in the vehicle or the system. And this touchscreen tablet can then interface with the driver or end user, and they can send information back to the control system and read information out of it. And again, it's a great way to develop a low-cost human-machine interface. Now we're going to go through just a quick example of an Android app that we've built up for a customer. You can see on this screen it's providing feedback for a number of different variables. It also has touch buttons to toggle on different features and has some LED-like indicators as to what the system's doing. This screen's interesting because it's a way for the user to set calibrations in the controller that's operating, and through that touch slider bar you can adjust different thresholds for giving the desired engineering calibration values, which can affect then the system performance, and the user can actually tune the system to their needs. Additionally, we have a data logging feature that we've built in the Android applications, and in this screen you can select which data and toggle it on and off, and then that data gets read from the CAN bus, converted to engineering units, and it can be stored either on the internal memory of the device or on an SD card if it supports that. Additionally, we've built up a basic CAN bus monitoring tool that can be downloaded that allows you to read the raw data off the CAN bus and send data as well at a very high rate, and it's just a convenient tool for monitoring the CAN bus from your phone or tablet. So now let's talk about some additional engineering or development tools that we see Bluejay fulfilling as part of this Raptor platform and enabling the intelligent machine. So the first one is mobile development tools. We see an opportunity and have started the development path for building Raptor Cal Mobile, which will allow you to have a formal calibration interface from which you can, through a tablet, calibrate a control system, flash new updates, manage calibrations and programs. So we see this as a great way to take the development into the field, put it in the user's hands, and allow some touchscreen and convenient mobile calibration development. Another market that we see for this tool is the use in developing low-cost service tools. So you have a vehicle in the field, you can either install the Bluejay device on the vehicle permanently, or you can have an adapter harness made so that the technician can plug the dongle into the vehicle and then be exposed to diagnostic reporting, monitoring of different variables for troubleshooting. Software updates can be performed, and data can be recorded and fed back to engineering as well. So we really see an opportunity for Raptor Service Mobile to take widespread adoption in enabling our customers and different industries to be able to service their vehicles easily in the field. Another application that we see is CAN bus analysis. So Bluejay supports high-speed data transfer to and from the control system, which means that we can develop an application that records data, saves it to the storage on the tablet, and then can be converted to engineering units. It's easy to simulate data and different engineering units that you want to send out onto the CAN bus, and it's just another great tool to use the Bluejay for. A final mobile development tool that we're interested in pursuing further is the ability to do an alternative to traditional telematics. With this solution, the Bluejay would interact with our existing back-end database and web portal through a mobile device that could stay on the vehicle or control system, or could be added whenever service is needed. This would allow you to remotely monitor data and engineering units from our web portal, as well as push updates down from the cloud to the device without actually having anybody on the vehicle. And another thing that we're excited about is that the tablets support either Wi-Fi or 3G, 4G cellular connectivity, so it gives you multiple options in how you connect to the cloud, which some of the tablets nowadays are down in the $50 range that support Wi-Fi, and this could be a really low-cost telematics solution. So now let's talk a little bit about availability. We have a limited number of engineering samples that are available immediately. We have Android drivers available, and we'd be happy to discuss any of these applications that we've talked through with you in more detail to see how it might fit your needs. We also have PC drivers that will be available in 4 to 6 weeks. The prototype price for this Bluejay is $495. The production price when we do our first run will be $295, and we anticipate that being in 6 to 8 weeks or sooner. And then obviously we've designed this to be a low-cost, high-volume component, so that in volume we will have very good price breaks. So that is kind of what we wanted to present today. We wanted to be concise and share lots of different opportunities and applications for this product, and then we'd like for you to now open it up for any questions that we may have, and Matthew is going to help me out with this. So we have if you didn't catch this, we have a way to submit questions through the webinar dashboard there, so go ahead and submit questions. We already have some that we'll go through, but please continue to send questions as you have them. So Matthew, you want to answer the first question?
Yeah, sure. So the first question we had was about the power requirements, how much current the device draws. It draws about 70 milliamps at 12 volts. It does use a switching supply, so that would drop a little bit with a higher voltage. So it would be possible to power it off of battery, but we do not currently have any low power like sleep modes at all.
And one question I have for you, Matthew, is if we used USB, we could disable the Bluetooth on the Bluejay, and that could potentially lower the power requirement.
Yes, that would lower the power significantly. In the future, we may add a low power sleep mode that would also limit the current draw to a very low state.
The next question on here is asking if RP1210 compatibility means that it'll work with something like the Cummins Insight calibration tool. You want to answer that, Matthew?
Sure. Any RP1210 compliant tool should work with any other RP1210 compliant device. And since we've added RP1210 compliance, it should work with any device that supports that, or any tool that supports that. We have not specifically tested it with the Cummins tool, but we'd be happy to test that out if it's needed. We've also had another couple questions about RP1210. We will be supporting RP1210C.
There's a question on here about if you were using two Bluejays at the same time, one on each can, would there be any issues connecting with a single tablet, I think is the spirit of the question.
I don't believe that most tablets would support two Bluetooth connections simultaneously, but we could certainly have both of them and then toggle between the connections.
There's a question on here about more detailed specifications for the device. If you're interested in that, just send us a note and we can provide more details on the hardware spec and what we're testing this product to. There's also a question on here about potential iOS iPhone plans. We have considered that and have investigated a little bit. As you may know, iOS is a little bit more strict in terms of how data can be sent and received both over Bluetooth and USB. We haven't investigated that in too much detail, but we're open to pursuing that development effort if that's a requirement for your program. There's a question here about potentially molding the Bluejay into a connector that fits the J1939 interface, 9-pin Deutsch interface, for example, or maybe the OBD connector interface. We have considered that, but with the number of different vehicles and systems out there, we started with the DB9 because that's a pretty standard interface. But we obviously have this design, and if the market and volume potential is good enough, we would be happy to mold it into a different connector. There's a question here about access to this presentation. It will be on our website shortly after the webinar, so be sure to look for that. It will be under past webinars.
There's also a question about connecting two programs at the same time. That may be a possibility. We've not tested it out. RP1210 does support multiple connections, and some of our other drivers will probably support that as well, but we'd have to test that out.
There's a question here about the cost for Android drivers. We are willing to either develop your application for you, or you can purchase the Android drivers, and if you're interested in that, just send us an email and we can follow up with you in more detail. There's a question about the ruggedized potential of this product. Again, we could obviously design this to any potential requirement. Right now we designed it for in-cab or a on-desk type of operation, but in the future we could obviously expand that requirement. There's also a question on here about whether or not we can develop the Android app for you. I think I mentioned it before, but I just wanted to be clear that yes, we have that capability. We have engineers familiar with the Android Development Studio, and we have the existing drivers built up, so we can do that pretty efficiently. And we found it works really well when customers share their graphics and what they're looking for in an end product, and we can seamlessly integrate that into an app for you that then you can own and distribute to your customers as needed. So here is Matthew and I's email address. So if you have any questions that haven't been answered here, or you'd like to talk about this in more detail, you can contact us or check out our website, or go send us an email at sales@neweagle.net too. Again, we want to thank you for listening in. Hopefully this was informative, and hopefully you're as excited about Bluejay and its applications as we are. Again, let us know if you have any questions, and have a great rest of your morning.